We have promised you a visit to our ICO in Paris, and here we are. I am with Régis Pajon, who is our site director, and he will take us through this fascinating experience here. So, Régis, thanks for having us.
You're welcome.
What is an ICO?
So an ICO is a real factory with real production invested by the BCG and created by the BCG to show to our clients, to our industrials, how the new technology could be a lever to improve the performance of the production.
Okay, very clear. We have looked at different technologies in our course videos, and I'm looking forward to seeing how those technologies work in the real world.
Yeah, so this is the goal, in fact, of the ICO, is to show the technology in action during real production. So I will just explain you on this first station, that is in fact a quality inspection station. So we have implemented three main technologies. So the first one is the MES. In fact, this is the manufacturing execution system that will do the link between the order of the clients and the production. For the scheduling, for example, also you will see to guide the operator on each operation they have to do. Okay, so you could see the tablet, and the operator will open an order of production, and you will see display on the screen also that you could have many information concerning the product we have to insert in the line with some indication about the serial number, the different variances, for example, the due date, the tag time, and so on, and an information concerning the operation he has to do with 3D models, with video, text, anything you want, in fact, to explain to the operator what he has to do. So after the MES, in fact, we'll send directly to the augmented reality the right checklist according to the product we have at the station. Okay, so I will just change to show you the augmented reality. So,
and that can adapt to both the scooter, because I know that's what we're seeing right now, the scooter production, but also to other products.
Yeah, sure. In fact, the goal is to guide the operator to save time in training first, and also to manage the diversity, because the operator is limited by his memory. And now the memory is in the systems. So it allows you to manage more and more variances without having to retrain the new operator or retrain the operator in case of introduction of a new product, for example. So you will manage more and more diversity.
Okay.
Okay. So with the augmented reality, you can see the real chassis. Okay. And you can see the 3D model of the part we have to check. So the use case that is presented here is a check by vision or by touching, but it could also mix with other devices to make the check being automatically done by complex devices as a 3D camera for the measurement, if you want, or anything else. But first, for the operator, it's just to select the part, okay, check if the part is okay, and fill the form. If the part is missing, you will see the 3D model that will change the color, or perhaps this part is not confirmed, or this part is confirmed, and do the same for the second part, and so on and so on and so on.
Okay, so augmented reality basically guides the operator really step by step on what he needs to do. So he looks, he validates, and that all flows back into a data aggregation system that then gives you the status of your scooter.
Yeah, exactly. The goal, in fact, once again, is to guide the operator and avoid the mistakes that can be done by the operator, because we are paperless. So the operator searching in papers, in files that are perhaps not updated, or in files that he has to, in fact, to find the right procedure, so to recognize the right product, find the right procedure, and could do mistake. So this is the system that will guide to avoid all the mistakes and save times.
Okay, excellent. And then where does the scooter go from here?
So the scooter, in fact, before the transfer, we will use a third technology, connected also with the augmented reality and the MES, and we are using, in fact, the RFID. So the radio frequency, through this antenna, we will write in this memory the characteristic of the scooter in order to be read at each station. And once again, when at the first station we will read this information, we will be able to display on the tablet the right work instruction according to the product we have at the station. Okay. So once again, no papers, okay? and no possibility for the operators to do mistakes.
So that's an element of Internet of Things where you have every element in the factory here has an identifier that knows if that's a scooter or a drying machine.
Exactly. So it could be a scooter, it could be a dryer machine, but you could also have all the options, all the variances. For the same scooters, you could have different variances with mirrors, no mirrors, colors different, part difference, design, what you want. And all is rated in this tag.
Okay.
So once the control is okay and we have rated all the characteristics in this memory, we will transfer the chassis directly on this automated guided vehicle that is autonomous and allows to remove the non-added value to move one part from one station to another with a forklift driver, for example, and so on. So this kind of robot is very autonomous and is flexible for you to change the different flows of production if you want with a very easy programming.
Okay, so let's go to the next station then.
Let's go. So now I would love to show you the first station where we will assemble the wheel of the scooter. So the weight of the wheel is 15 kilograms, so it's quite difficult for the operator to lift this kind of load all the day. So we have decided to implement a collaborative robot. So a collaborative robot is in fact a classical one, but equipped with different sensors that will detect the contact with an obstacle or with the operator and stop immediately the motion. So it allows you to work very closely in a collaborative mode with the operator and the robot. So first, during the introduction of the chassis, the robot will automatically pick a wheel and approach the wheel close to the chassis, and the operator will take manually the robot and adjust the position.
Okay.
Okay?
So the first part is completely autonomous, and then the operator is coming here only to adjust the last final details.
Yes, exactly. So what is very interesting with the collaborative robot in general is that due to this functionality to stop the motion in case of contact, you will be able to place a robot without having to implement fencing and safety cell. So it allows you to implement those kind of robots on an existing plant without having to redesign the plant and also to work together with the operator.
And again, you told me that this is a programmable robot, so you can program it to take the wheel, but you can also program it to work with a dryer machine rather than a scooter.
Yeah, exactly. In fact, you can see at the first station we have the scooter and the robot will help the operator to assemble the wheel. But at the second station, if we have a tumble dryer, the robot will take the sides of the tumble dryers because the robot is connected to the PLC and connected to the MES and will receive the order of production. So it knows exactly what is the kind of product we have at this station. So what is also very interesting is that with the collaborative robot, not only this one, but all the other models also, the interface are very user-friendly, and you don't have to be an expert in robotics to program them. So you just have to move the robot and press the button to teach the position, move the robot again in the second position, and so on, and the robot will repeat the motion. So the operator can do the program by himself.
Okay, I like it a lot. And I like this idea of how training is also transformed with different technologies, right? And I want to take us to the next station where training operators becomes also much faster than how we usually used to do it in plants.
Yes.
Shall we go there?
Yeah. So now I will show you a sub-assembly station. So, because we have to train our operators, we need to have a tool to guide them once again. And we will show you how this new technology could help to train the operator. So you will have all the work instruction directly projected in the table that is not touch sensitive. But the system will recognize my finger and allows me to change the step.
Okay.
Okay? So you could have some hints with different lights that show you where to place the part, how pick the parts directly with the lights, with the pick two lights, and place the part at this position. So you can click next. So you have a control on this part about the electronic components. click next, see the arrow to place the part. Okay, next. You could do an inspection just by pressing the foot pedal. We will take a picture, and if the assemble is okay, I could go to the next step. If the assemble is not okay, I will be blocked in this step, in fact. Okay? So this is the way you have to train your operators and save time for the training, because you will just train the operator to use the technology. Your trainer will not stay with the group of trainees all the day. The trainer will train how to use the technology and go to another group, for example.
Yeah. Okay. And I liked when you told me that this is not really augmented reality, it's projected reality.
Yeah,
right?
Exactly. Because we will not add a virtual element on the real view. This is quite different.
Yes. And Régis, there is one last thing that I would like to show here in the ICO, which is additive manufacturing.
Yeah.
We have talked about it in the course, and I'd love to see what you're doing with it in here.
Okay, let's go. So now we will see the additive manufacturing. In fact, this is the 3D printing. The first use is, in fact, the fast prototyping. You could also, it allows you to make different designs that are not possible to do with the classical machine, for example, or to create spare parts for the tools or for the product and so on. So you have a multiple, in fact, usage.
So the idea here is that we're having the scooter, but we're not going to build all the spare parts with the scooter when it's first manufactured.
Yeah.
We're going to build them once they are needed.
Yeah, sure. You can produce on demand.
Fantastic. I love it. So Régis, thanks a lot for having us in here in our Paris ICO, and I'm looking forward to coming back for a longer, more extensive visit.
Thanks for coming.
Thank you.